My name is Adilcan and my partner's name is Alberto. We are doing a project for our embedded systems class. Our project is related to archery and we decided to call it Archery Buddy. We both have started archery club in Purdue this semester and we found out that the learning process in the beginning can be improved by using an embedded system. In the beginning, new archery students try to learn different things at the same time to perform their first shooting. To be able to group their arrows, in other words, for precision, archers need to shoot in the same manner all the time. They need to pull the string the same distance, the arrow should be pointing at the same angle in vertical and horizontal, and also the bow should be tilted the same amount. Having the absence of a feedback system to tell the archer whether he or she is aiming in the same manner is the starting point of our project. So we are trying to improve the precision of beginner archers so that they can learn grouping their arrows faster around the point when they first start. So later they can improve their accuracy themselves since they have already learned how to do precise shooting and their body is used to that by the help of our project.
Hello, my name is Alberto and this is our full portable device. That means it can be used almost in any recurve bow, which is the one this shape. Our device is composed with a battery that provides enough power to power up this device. That means that the archer does not need to have any cable going into his pants or going to an outlet in the wall. It is portable, it is lightweight, and it does not bother the archer. The main components for this are a flex sensor over here, an accelerometer over here, and a laser beam. These three together will help the archer improve their precision while they are shooting. The flex sensor is used to measure how much the bow bends. That is, when a person draws, the bow bends. The more the person draws, the more the bow bends, and we get different measure data. We use this to tell the archer if the pulling is too little or too strong to keep most the steady position. The accelerometer in this case is used to measure the vertical axis and the tilt of the bow. And combined with the laser sensor, we can get the horizontal axis reference. To power on the device, we click on the switch over here. As you can see, at the splash screen we start showing on the display. It will last for 20 seconds. This time is necessary for the accelerometer to calibrate. It is recommended to take the bow as steady as possible or to place it in a surface where it can be placed. The logic is controlled by the brain of this device are two Arduinos. One of them controls the accelerometer, the flex sensor, and all the algorithms behind. The second one controls mainly the displays. This approach was made because all the libraries were too heavy for a single Arduino to handle them. The last element is a button over here. It is a restart for the positions of the archer shooting.
So now the power is on and the system is actually right now tracking, but it doesn't display anything on the LCD screen because it is waiting for me to shoot an arrow, and when I shoot the arrow it will record that data and then it will ask me to read the same data again so that I will be shooting at the same point. So right now I will shoot an arrow. So the laser is helping me to as a reference point in the horizontal. So here the top value, the yellow one, is the tilt, and the second one is the angle in the vertical. So when I am too high, it asks me to go down. When I am too down, it asks me to go up. So the tilt is now at 0. Now the angle in the vertical is at around 0. And the last one is the strength of the pull. So I will actually shoot the second arrow now, and let's see if my second arrow goes somewhere close to the first one. So I'm using the laser to point at the target. My arrow actually went somewhere here, but I was looking, the laser was pointing here. So now So right now the pull is good, a little bit down, a tilt, trying to make everything zero, but it's already blinking, so when it is blinking it means it's good enough to shoot. So let's see if the arrows are at the close together.
So as we can see, the two arrows that were shot, they're pretty much on the same line. This is pretty much working on precision rather than accuracy. Accuracy will be giving the target in the middle where we were actually shooting, but rather we were hitting the arrows to a side. If we make this shot, we can see that they're pretty much close to each other, only drift a little bit by distance. As we can see on the previous record, my partner did not make the force zero, so that's why they get a little bit off to each other. Well, sometimes you have to go around, get all your arrows, and then come back to a new place, or even let your bow to your friend. So that means you need to restart the position. That's why we have this button over here. After you press it, you can see that this display showed tracking a new position. That means that I can simply shoot a new arrow with the force I want, with the tilt I want, and it will create track for me. So after shooting the first arrow, I go for the second one. Try to make everything zero. Ooh, pretty close. So let's see how I do this time. You have more arrows? For example, here it says to pull more, tilt up, down, pull less, more tilt. Cool. Let's look at how I did. So we can see 3 arrows over here, one top, one at the bottom. But if we look from the bottom side, like a down take, it just hit right on top from this place. As we can see, not all the arrows are on the exact same location. This is because also we have the human error. When the person are holding, people are shaking. So that shaking also moves around the position of the target. So even though we indicate that you have same angle, same jaw, same vertical position, same force, when people actually shooting, they get some arrows. So we get something like this. But for the purpose of the device is great. Instead of having an arrow shooting to a tree or more down into the ground, we're hitting almost all of them into a target.